In this video, we're going to talk about how to calculate the molarity of the solution, or the concentration of the solution. So first, you need the equation. Molarity is equal to the moles of solute divided by the liters of solution. So it's moles divided by volume. Now you need to know what is meant by the terms solute and solution. So let's say if we dissolve salt and water. Individually, the salt is the solute. Water is the solvent. The solvent dissolves the solute. And together, the combination of the solute plus the solvent is the solution. So keep that in mind, so that'll help you to distinguish the solute from the solvent. So now let's work on this example. Let's focus on part A. 0.25 moles of sodium chloride in 300 milliliters of solution. What is the molarity of that solution? So we're given everything that we need. We have the moles of the solute. Sodium chloride dissolves in the solution. And we have the volume of the solution. However, we need to convert it to the units liters. And to convert milliliters to liters, simply divide by 1,000. 1 liter is equal to 1,000 milliliters. So 300 divided by 1,000, it's 0.3. Another thing that you can do is move the decimal 3 units to the left. So let's divide this by 0.3 liters. And 0.25 divided by 0.3, that's about 0.83. So that's the concentration of the first solution in part A. Now let's move on to part B. Now keep this in mind. Molarity is moles of solute divided by liters of solution. This will be helpful throughout parts B and C. So for part B, I'm going to do more of a conversion process. Let's start with 60 grams of sodium hydroxide. Now I need to get moles. I want to have the unit moles on top, and on the bottom the unit liters. So let's convert grams to moles, and we need to find the molar mass of sodium hydroxide to do that. So we need to add up the atomic mass of sodium, oxygen, and hydrogen. So sodium is about 22.99, oxygen is 16, hydrogen is 1.008. So this is 39.998. But for all practical purposes, let's round it to 40. So we can say that 1 mole of sodium hydroxide has a mass of 40 grams. So now we no longer have the unit grams of sodium hydroxide. Now all we need to do is take the moles and divide it by the liters. But we need to convert 250 milliliters to liters. So if you take 250 and divide it by 1,000, you'll get the volume in liters, which is 0.25 liters. So notice that we have the unit moles on top and liters on the bottom. Whenever you have that, your answer is the concentration in molarity. So it's 60 divided by 40, and then take that result divided by 0.25. So the concentration is 6 molar, or 6 moles per liter. So that's the answer for part B. Part C. Let's find the molarity of the solution when 700 milligrams of potassium iodide is dissolved in 200 milliliters of solution. So let's start with what we're given. Now we need to convert milligrams to grams, and then grams to moles, and then take the number of moles divided by the liters. 1 gram is equal to 1,000 milligrams. And now we need the molar mass of Ki. The atomic mass of potassium is 39.1, and the atomic mass of iodine is 126.9. So the sum is 166 grams per mole. So 1 mole of Ki has a mass of 166 grams. Now the last thing we need to do is take the moles divided by the number of liters in the solution. So 200 milliliters, if you divide that by 1,000, that's 0.2 liters. And so that's going to give us the answer. So it's 700 divided by 1,000 divided by 166 divided by 0.2. So the concentration is 0.0211. So that's the molarity of the potassium iodide solution. Number 2. 50 milliliters of ethanol is dissolved by 400 milliliters of water. What is the concentration of ethanol in the solution? So which one is the solute and which one is the solvent? The solute is dissolved by the solvent. The solvent is water in this problem. The solute is ethanol. Typically, the solvent is usually in greater quantity than the solute. We have a lot more water than ethanol, so water dissolves ethanol in this case. Now, in order to find the concentration, we need to calculate the moles of the solute. So we got to get the moles of ethanol and then divide it by the liters of the solution. Now, if you recall, the solute plus the solvent combined makes up the solution. So what is the volume of the solution? We have 50 milliliters of solute, 400 milliliters of solvent. So therefore, we have 450 milliliters of solution. And if you divide that by 1,000, that's 0.45 liters of solution. So we're going to use that later. So now we need to focus on finding the moles of the solute, which in this case is ethanol. So we have the volume and we have the density. Combined, we can use that to get the grams of ethanol and then convert that into moles. By the way, here's the formula for ethanol, C2H5OH. So you can always look that up on the internet or something. So let's start with the volume of ethanol. We have 50 milliliters of ethanol, and the density of ethanol is 0.79 grams per milliliter. So now we have the mass of ethanol in grams. So now we can convert that to moles, but we got to find the molar mass. So ethanol contains 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom in a single molecule. So this is 2 times 12.01 plus 6 times 1.008 plus 16. So this adds up to 46.068 grams per mole. So that's the molar mass of ethanol. So 1 mole is equal to 46.068 grams. Now the last thing we need to do, once we have moles, is to divide by the number of liters, which we know it's 0.45. So once you have these 2 units, moles divided by liters, you now have the molarity of the solution. So it's 50 times 0.79 divided by 46.068, and then take that result divided by 0.45. So the concentration is 1.905. So that's the molarity of the solution. Number 3, the concentration of aluminum sulfate is 0.3 moles per liter. What is the concentration of the aluminum and sulfate ions? Well, first, let's write the chemical formula of aluminum sulfate. Aluminum is found in group 3A of the periodic table, so it has a positive 3 charge. And sulfate is one of those polyatomic ions that you should know by now. It's SO4 2-. And so the chemical formula is going to be Al2SO4 3. And the concentration is 0.30 moles per liter. So based on that, what is the concentration of the aluminum plus 3 cation? So notice that we have a subscript of 2. So it turns out that to find it, all you got to do is multiply the molarity by 2, so it's going to be 0.60. And in the case of sulfate, there's 3 of them per formula unit, so it's going to be 0.30 times 3, which is 0.90. Now, for those of you who need to show your work, here's what you can do. The first thing you should do is write the dissolution of aluminum sulfate. Aluminum sulfate breaks down into 2 aluminum cations and 3 sulfate ions. So you could say this is the solid phase, and on the right, the aqueous phase. So I'm going to represent this as 0.3 moles of aluminum sulfate per liter, because that's what it is. Molarity is moles per liter. Now we can use the molar ratio to convert from, I'm going to use sulfate as an example. So from aluminum sulfate to sulfate, it's a 1:3 ratio. So for every 1 mole of aluminum sulfate that dissolves, 3 moles of sulfate ions are released into the solution. So the unit moles of aluminum sulfate will cancel. So now what you have left over is moles of sulfate per liter of solution. So it's 0.3 times 3, and so this will give you 0.9 moles per liter, which you could say that's 0.9 molar sulfate. So that's the concentration of sulfate. That's how you could show your work if you want to. But the simplest way to get the answer is to take 0.3 and multiply by the subscript, and that will give you 0.9. Number 4. 15 grams of iron 3 chloride is dissolved in 450 milliliters of solution. What is the concentration of chloride? So let's get the answer just completely using conversions and dimensional analysis. Let's start with 15 grams of FeCl3. Now, in order to get the concentration, we need to convert this into moles. And at the same time, we need to change the substance from FeCl3 to Cl-. So that's going to require an extra step. But first, let's calculate the molar mass of FeCl3. So we have 1 iron atom and 3 chlorine atoms. The atomic mass of Fe is 55.85. And the atomic mass of Cl is 35.45. So you should get a molar mass of 162.2 grams per mole. So 1 mole of FeCl3 has a mass of 162.2 grams. So now let's change the substance from FeCl3 to Cl-. There's 1 chloride ion per formula unit of FeCl3. So therefore, we could say that 1 mole of FeCl3 will release 3 moles of chloride ions in a solution. It's a 1:3 ratio. Now that we have the moles of chloride ions, all we need to do is divide it by the liters of solution, and that will give us the concentration of chloride. So let's divide this by 1,000 to convert it to liters. So that's 0.45 liters. So this is going to be 15 divided by 162.2 times 3 divided by 0.45. So the concentration of chloride in a solution is 0.617 moles per liter, or capital M. So that's the molarity of the solution, of the chloride in a solution. Number 5. What mass of ammonium chloride is required to produce 250 milliliters of a 0.75 molar ammonium chloride solution? So we're given the molarity and the volume. How can we find the mass? The best way is to convert it. I'm going to start with the molarity of the solution. So keep in mind, capital M, molarity, you can represent it as moles per liter. So a 0.75 molar solution means that we have 0.75 moles of ammonium chloride per liter of solution. Now, we're not going to change the substance, so we don't need to write NH4Cl. So I'm just going to write this, 0.75 moles per liter. Now, we have the volume of the solution, 250 milliliters, and if we divide that by 1,000, that's 0.25 liters. So you want to multiply the molarity by the volume because, if you notice, the unit liters will cancel, and now we have the moles of ammonium chloride. So all we got to do is change moles to grams, and we can do that using the molar mass. So in NH4Cl, we have one nitrogen atom, 4 hydrogen atoms, and a Cl atom. Nitrogen is 14.01, H is 1.008, and Cl is 35.45. So the molar mass is 53.492. Now, because we have the unit moles on the top left, we need to put the moles on the bottom. So 1 mole of NH4Cl has a mass of 53.492 grams. So this is going to be 0.75 times 0.25 times 53.492. So the answer that I got is 10.03 grams of NH4Cl. So if you're given the volume and the molarity and you want to find the mass, you need to take the molarity and multiply it by the volume in liters and then multiply it by the molar mass of the substance. That's going to give you the grams of the substance. Number 6. What volume is required to dissolve 8.5 grams of potassium nitrate to produce a 0.15 molar potassium nitrate solution? So this time we're given the mass of the solute, the molarity of the solution, and our goal is to find the volume. We're going to find the volume first in liters, and then we're going to convert it to milliliters. So how should we begin? Now, if we want to get liters on top, that means molarity has to be on the bottom. We don't want to start with molarity because that's going to be moles per liter. However, we need to flip it at some point because we want this unit to be on top. Just keep that in mind. So let's start with the mass. 8.5 grams of KNO3. And here's the basic setup that I'm going to do. I'm going to start with the grams, and then using the molar mass of the substance, this will give me the moles. And using the molarity, I'm going to get the liters on top, which is what I want. So that's just a blueprint of how I'm going to set up the conversion process. And I don't like when the whole thing just disappears like that. So we need to find the molar mass of KNO3. Potassium has an atomic mass of 39.1, N is 14.01, and O is 16. 3 times 16, that's 48. And 48 plus 14.01, that's 62.01. And then let's add 39.1 to that. So this is 101.11. So there's 101.11 grams per 1 mole of substance. Now let's use the molarity of the solution. So a 0.15 molar solution means that there's 0.15 moles of solute per 1 liter of solution. In order to get the unit moles to cancel, we need to flip this fraction. So we're going to put the 0.15 moles on the bottom and 1 liter on top. So it's 8.5 divided by 101.11, and then take that result divided by 0.15. So it's 0.56 liters. So that's the volume in liters. And if you want to convert that to milliliters, all you need to do is multiply by 1,000. There's 1,000 milliliters per liter. So this is going to be about 560 milliliters.